Alright, so let's try another one. We're going to try to balance this reaction. This is the combustion of methane with oxygen. You can tell it's a combustion because it makes CO2, carbon dioxide, and water, and also some heat. And we'll mess with this reaction next time I see you some more. So if we're taking CH4 is the methane, you have one carbon and four hydrogens. And we're also going to take oxygen. That's what helps things oxidize or burn. And eventually what will come out as carbon dioxide, CO2 and H2O. If we break down one of these molecules, say this one, we want to turn it part of it into CO2 and then H2O. So the CO2, this piece, maybe we should duplicate it, right? So let's duplicate this piece. And on this side of the equation, we have our CO2. We're going to need two of these. So there's CO2. And also we need H2O. If we took this molecule and stripped it of its O's, you'd need two of the hydrogens. Here they go. There's one, two. To make the H2O, but we're also missing, we've used up the two O2s, right? We need another set. They only come in twos, so we're going to take another set, and we're going to break this into this O2 will go with that, this one will go with that. So if you look at this, step back for a second, we have one CH4, and because we only have one carbon in there. That's sort of the most unique piece in there. We're going to get one CO2. We're going to get one set of that. There's one of them. And also we're going to make, going to use these H4s, these two blues and these two blues, to make some waters, H2O and H2O. And we're going to get here, we're going to get two of those out. So really we had one of these. We'll get one CO2 out, and we'll get two H2Os out. But that'll mandate that we have 1, 2, 3, 4 oxygens. So we're going to need 4 of these, right? So really we're going, 4 oxygens, 2 molecules. So we're going to need 2 of those. Yeah? And so you can think about that this way. If you broke this down again and said, all right, I want one of these and 2 of these. It's sort of like they'll go in perfectly to make one carbon. So let's duplicate all of these. Oh, I got the line too. That's great. We've got one CO2. Here are the O2s, so let's grab one of those. Right, so the carbon from CH4 went to the carbon from CO2. And then we've got H2. These were the H's, so there's an H2, and an O goes with those. And here's the H2 and O from the second one. Yeah, so we have one CH4, 2 sets of O2, and we get one CO2 and 2 sets of H2O. Great. You can see that visually with this as well. Maybe it's a better pictorial representation that this is a nice balanced equation because we have, here's the single carbon and a single carbon. We have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens, and we also have 1, 2, 3, 4 oxygens, and 1, 2, 3, 4 oxygens, right? So everything's accounted for. There's been no matter created or destroyed. This is a chemical reaction, not a nuclear reaction. Great. And so that's balancing equations. We'll try a couple more together. What I'd like you to do is to jump on the VLE in a second and try this with the PhET demonstrations. Maybe I'll show you one, but if you click on this guy, it'll pop up, and there's 3 different types. We're just going to go for introduction. there's 3 different types of reactions. You can either make ammonia, separate water, or combust methane. We've done this N2H2 together. So start by just putting in 1 here and see if you can get 1 out, right? I have 1 nitrogen, so it's probably unlikely that I can take 2 of these and get 1 nitrogen. So this is going to have to be 2 nitrogens, and now I have 6 hydrogens, 3 there, 3 there. So I'm going to need 6 hydrogens to come from here. So I'm going to need 3 of those, right? And when you get it right, you get a nice smiley face. Wahoo! And also you can put in some balance beams to make sure everything balances, right? Decrease the hydrogens, and on this side there's too many hydrogens. So that means that on this side you need more hydrogens. Being balanced, right? Or here, oh, too many nitrogens on this side, so we need to add more nitrogens to this side or take some away. Does that balance? Oh, now we're getting closer. Nitrogens are still too heavy on this side, so add some more on there. I can't add some more, so we're gonna have to back it off and find the correct amount with that, right? So try that with the separation of water. Try that with combustion of methane, and see if you can get all the pieces to balance out. When you're done with that, and are a little bit confident in that, your homework is this balancing equation sheet. There's 10 problems of increasing difficulty. I've put in some of the numbers for you to get you started. So let's look at the first one together, and then you're on your own. So with this, we have KOH and H3PO4 turning into the products over here. Because I'm nice to you, I said let you know that there's 3 of these and 1 of these being reacted. So we have to figure out what's going to be the product of that. Here, there's 3 that are labeled here, and so it's only our job to figure out how many of these do you need. So I see that I have 3 H's here, and we're going to do an audit. I'm going to say I have the H's here on this side. Because this side's complete, I know that I have 3 H's, right? And also I have 3 more H's because I have 1 of these molecules, so in total you get 6 H's on this side. I have 3 K's on this side, and 1 P, so I've got 1 phosphorus, and I have 4 oxygens, right? And I have 1 set of these 4. Oh, I have 4 oxygens here and 3 sets of those, so I have 4, 7, right? So I have 7 oxygens. Sweet. And so we need to balance that on this side. Over here, this has 6 hydrogens already, which is nice, right? That's nice and balanced. We can tell because I have 3 of these H2s, and so there's 6, which also means we have 3 oxygens. There's some here that might be left over. I'm not sure what to do with those yet. What I'm guessing is we should put 1 here, because then we would have 3 Ks, right? We have 3 Ks there, K3. So then this would be K equals 3, and we'd have 1 phosphorus, right? P is 1. And if we have 3 of these, then we have 3 oxygens and 4 more oxygens. So our oxygen is 7. And so this is balanced with 3, 1, 1, 3. You're going to try that with the rest of them. If that's a little fuzzy for you still, you can rewatch this video, or Khan has a nice video that's up on the VLE about balancing equations as well. Might give you a little extra boost, and I will see you tomorrow. Okay, bye.